Look up at the night sky. What do you see? A scattering of stars, maybe a planet or two, the gentle arc of the Milky Way. It all seems peaceful, predictable, even ordinary. But what if I told you that hidden in the vast darkness are structures so strange, so utterly baffling, that they shouldn't exist at all? These aren't just quirks of the cosmos. They're full-blown enigmas that defy the laws of physics as we know them. Picture celestial formations stretching across unimaginable distances, cosmic oddities that leave even the brightest astronomers scratching their heads. These are not just mysteries, they're cosmic rebellions, daring us to question everything we think we understand about the universe. Now, consider this. Somewhere out there, a cluster of galaxies aligns in a pattern so precise it feels intentional. A supermassive black hole spins faster than science says it should. A void in space stretches billions of light-years wide with absolutely nothing inside. These aren't science fiction, they're real, documented, and utterly inexplicable. And today, we're diving headfirst into 30 of these deep space anomalies, each one more mind-bending than the last. From megastructures that seem engineered by some unseen hand to celestial phenomena that rewrite the rules of reality, these discoveries don't just push boundaries, they shatter them. So why should you care? Because these aren't just distant curiosities, they're clues. Pieces of a puzzle that could redefine our place in the cosmos. Every strange structure, every impossible formation whispers a question. What if we've been looking at the universe all wrong? What if the answers we've clung to are just the beginning? This isn't just a tour of cosmic oddities, it's an invitation to wonder, to challenge, to explore. So settle in. By the time we're done, the night sky will never look the same again. Let's start with the Fermi Bubbles, two enormous, glowing orbs of gamma-ray energy erupting from the heart of our galaxy like a cosmic hourglass. Picture this, structures so vast they stretch 25,000 light-years above and below the Milky Way's disk, dwarfing everything else in their path. When scientists first spotted them in 2010, the discovery sent shockwaves through the astronomy community. Here's why these bubbles shouldn't exist. Their energy signature is off the charts, blasting out gamma rays with no obvious power source. Think of it like finding twin lighthouses in the middle of the ocean, blazing light into the void, but with no lighthouse keeper, no fuel, and no explanation for how they've been shining for millions of years. The leading theory: a supermassive black hole at our galaxy's center might have gone berserk in the distant past, devouring unimaginable amounts of matter and belching out these bubbles as a cosmic afterburner. But here's the catch: even that explanation doesn't quite fit. The energy required would be like a nuclear bomb lighting up a continent, yet leaving no crater behind. And the mystery deepens. These bubbles aren't just big, they're perfectly symmetrical, as if some unseen hand sculpted them. Natural phenomena rarely produce such precise, mirrored structures. So what's really going on? Could it be the aftermath of a black hole's feast, or something far stranger, like dark matter annihilations or even echoes of a long-lost galactic collision? Every answer raises new questions, and that's what makes the Fermi Bubbles one of the most tantalizing enigmas in modern astronomy. They're a reminder that even our own backyard in the cosmos still holds secrets we're only beginning to uncover. Now let's shift our gaze to something even more unsettling: an invisible force yanking entire galaxies, including our own, toward an uncharted corner of the cosmos. Meet the Great Attractor, a gravitational anomaly so powerful it bends the paths of thousands of galaxies like a cosmic puppeteer. Imagine floating in a river you never knew existed, swept along by a current you can't see or explain. That's the reality for our Milky Way and its neighbors, all hurtling toward this mysterious point in space at over 2 million kilometers per hour. What makes this so bizarre? For starters, we can't even see it. The Great Attractor lurks behind the thick dust and stars of our galaxy's central bulge, shrouded in what astronomers call the zone of avoidance, a frustrating blind spot where the Milky Way's own brilliance blocks our view. Early attempts to study it were like trying to map a hidden valley by listening to echoes. But here's what we do know. Its gravitational pull is colossal, equivalent to tens of thousands of Milky Ways crammed into one region. The strangest part, there's no obvious supercluster or massive object there to justify such a force. So what's tugging at us? Some theories suggest it might be an unimaginably dense knot of dark matter, the invisible glue holding galaxies together. Others propose it's the heart of the Laniakea supercluster, a galactic metropolis we're only beginning to map, but even these explanations fall short. The Great Attractor's influence stretches beyond Laniakea, pulling galaxies that shouldn't logically be connected. It's as if we've discovered a hidden conductor orchestrating movements on a scale we barely comprehend. And then there's the chilling possibility: what if it's not the final destination? Some data hints that the Great Attractor itself might be drifting toward something even larger and more mysterious, the Shapley supercluster, a gargantuan assembly of galaxies 8 times more massive. This cosmic matryoshka doll of gravitational puzzles forces us to confront a humbling truth. We're not just passengers on a random journey through space. We're caught in a web of forces we're only beginning to trace, where every answer peels back another layer of questions. The Great Attractor isn't just a curiosity, it's a gravitational siren call, drawing us deeper into the universe's best-kept secrets. Next, we encounter a celestial masterpiece so flawless it looks almost artificial: Hoag's object. This stunning ring galaxy floats in space like a cosmic bullseye, its golden circle of stars framing a hauntingly empty center. At first glance, it could pass as a ripple in a pond or a splash of paint across the cosmos. But here's what makes it extraordinary. It defies every textbook explanation of how galaxies form. Most galaxies, like our Milky Way, are messy spirals or lumpy ellipticals, shaped by collisions and chaos over billions of years. Hoag's object, though, it's perfect. The numbers alone are baffling. The ring spans roughly 120,000 light-years larger than our entire galaxy, yet its core is eerily vacant. No dense cluster of stars, no supermassive black hole lurking in the shadows, just a quiet, dark void encircled by a radiant halo of young, blue stars. Theories suggest it should be the aftermath of a galactic collision, where one galaxy punched through another, sending stars rippling outward like stones tossed into water. But there's no debris, no trail of destruction, no second galaxy nearby to blame. It's as if the universe delicately placed this ring on a velvet cushion and said, "No fingerprints allowed." Even stranger, the ring itself is too pristine. Normally, such structures would warp or fray over time, tugged by gravity or littered with the scars of ancient collisions. Yet Hoag's object remains symmetrical against all odds, its stars orbiting in near-perfect harmony. Astronomers have scoured the area for clues, perhaps a long-vanished intruder galaxy or a freak resonance of dark matter, but every lead fizzles out. The only similar object we've found, a distant ring galaxy called AM06444741, shares the same eerie perfection, deepening the puzzle. Could this be evidence of an entirely new way galaxies can form? Some researchers toy with the idea of a quenched core, a galactic center that somehow starved itself of star formation, leaving the ring as its sole survivor. Others wonder if invisible forces like dark matter filaments sculpted it into this rare shape. But for now, Hoag's object floats in silent defiance, a cosmic anomaly that refuses to fit into our neatly labeled boxes. It's a reminder that the universe doesn't just break rules sometimes, it rewrites them entirely. Now, prepare to have your sense of scale utterly demolished. The Hercules Corona Borealis Great Wall isn't just large, it redefines the word enormous. Imagine a structure so vast it would take light 10 billion years to travel from one end to the other. That's over half the age of the universe itself. This isn't a galaxy or a cluster. It's a sprawling, thread-like superstructure of galaxies, a cosmic tapestry woven across the heavens. And here's what makes it impossible. According to everything we thought we knew about the universe, it shouldn't exist. The cosmological principle, one of astronomy's foundational ideas, states that on the largest scales, the universe should appear roughly uniform. No dramatic clumps, no overwhelming voids, just an even distribution of matter. But the Hercules Corona Borealis Great Wall laughs in the face of that principle. It's not just a slight irregularity, it's a glaring exception, a cosmic mountain range towering over what should be a flat, featureless plain. Picture stirring cream into coffee and finding, instead of a smooth blend, an entire continent floating intact in your cup. That's the level of contradiction we're dealing with here. When astronomers first mapped it in 2013, the data seemed almost unbelievable. How could gravity alone assemble something so colossal? Galaxies within this wall aren't just loosely grouped, they're bound together in a delicate, filamentary dance, strung across the void like pearls on an invisible necklace. The sheer scale challenges our understanding of how matter clusters in the early universe. Some theories suggest it might be the remnant of a primordial quantum fluctuation, a ripple in the fabric of spacetime so ancient it predates the first stars. Others speculate it could be evidence of exotic physics, like cosmic strings, hypothetical defects in the universe's structure left over from the Big Bang. But the most unsettling possibility, this might not be the only one. If structures like this exist hiding in plain sight, our entire framework for cosmology might need rewiring. The Hercules Corona Borealis Great Wall isn't just a curiosity, it's a cosmic rebellion, forcing us to question whether we've fundamentally misunderstood the architecture of reality itself. And somewhere out there, even larger walls might be waiting, lurking just beyond the edges of our maps. Deep in the constellation Boötes lies a cosmic desert so vast and empty it defies comprehension, the Boötes Void. Picture a sphere of darkness stretching 330 million light-years across, a region of space where galaxies should thrive by the thousands. Instead, astronomers have found fewer than 60. That's like standing in the middle of an empty football stadium the size of Earth and spotting just a handful of grains of sand scattered in the corners. This isn't just a quiet pocket of the universe, it's a staggering anomaly, a place where the rules of cosmic structure seem to have been erased. When scientists first discovered the void in the 1980s, the initial reaction was disbelief. How could a volume of space that large be so barren? Galaxies typically cluster together, drawn by gravity into sprawling superclusters and filaments. But the Boötes Void is the opposite, a bubble of near-nothingness in a universe that's supposed to be brimming with matter. If our Milky Way sat at its center, we wouldn't have known other galaxies existed until the 1960s, when telescopes finally became powerful enough to peer beyond the void's edges. Theories attempting to explain this cosmic emptiness range from the plausible to the mind-bending. One leading idea suggests it's the aftermath of an unfathomably large collision between regions of dark matter, the invisible scaffolding of the universe. Imagine two vast, ghostly tsunamis crashing together in the early cosmos. their gravitational waves clearing out galaxies like a broom sweeping dust from a floor. Others propose it's a fossil from the universe's infancy, a quantum fluctuation frozen in time, a place where matter simply never condensed like it did everywhere else. But the most radical explanations venture into speculative territory. Could the void be evidence of a parallel universe brushing against our own, its gravitational influence subtly stealing matter from our cosmic neighborhood? Or perhaps it's a cosmic bruise, the imprint of some cataclysmic event in a higher dimensional space we can't yet perceive. Even the mundane explanations feel extraordinary, like the idea that smaller voids merged over billions of years, creating this colossal pocket of nothingness through sheer cosmic chance. What's truly unsettling is that the Boötes Void might not be alone. Other supervoids have been spotted, each one a challenge to our understanding of how the universe organizes itself. These aren't just empty spaces, they're cosmic puzzles, forcing us to confront how little we know about the large-scale structure of reality. The Boötes Void isn't just a lack of something, it's a presence in its own right, a silent reminder that the universe still holds mysteries we're only beginning to glimpse. On Saturn's North Pole, a storm rages with such mathematical precision it looks like it was etched into the atmosphere by some celestial architect. The Saturn Hexagon, a swirling, six-sided jet stream large enough to swallow 4 Earths, spins in perfect symmetry, its razor-sharp angles defying every law of fluid dynamics we know. Hurricanes on Earth are chaotic spirals, twisting and fading with the whims of the wind. But this is a geometric enigma that's outlasted generations of human observers, first spotted by Voyager in the 1980s and still churning today with undiminished ferocity. What makes it so baffling isn't just its shape, it's the persistence of that shape. Saturn's atmosphere is a maelstrom of hydrogen and helium, a place where turbulence should erase any rigid structure within days. Yet the hexagon's edges remain as crisp as if they were drawn with a cosmic protractor. Imagine stirring a cup of coffee and watching the cream form a perfect hexagon that refuses to dissolve, no matter how violently you swirl it. That's the level of impossibility we're dealing with here. Scientists have scrambled for explanations, running elaborate computer simulations to recreate the phenomenon. One leading theory suggests it's a standing wave, like a note held in a giant atmospheric organ pipe, where the planet's rotation and wind shear conspire to lock the storm into this bizarre shape. Others propose it's a manifestation of deep-rooted turbulence, where faster-moving polar winds shear against slower currents, creating a cascade of smaller vortices that somehow snap into geometric order. But even these models can't fully replicate the hexagon's eerie stability or explain why it doesn't appear anywhere else in the solar system. Then there's the mystery of what lies at its center. The hexagon isn't just an empty outline. It's a wall of winds whipping at over 300 kilometers per hour, encircling a vortex so deep it plunges hundreds of kilometers into Saturn's cloudy abyss. Some observations suggest the entire structure might be rooted far below the visible cloud tops, hinting at forces we can't yet measure. Could there be some hidden interaction between Saturn's atmosphere and its interior, a dance of magnetic fields or convection currents we've yet to map? The hexagon stands as a humbling reminder that even in our own cosmic neighborhood, nature can produce phenomena that look more like art than accident. It challenges us to rethink what we know about planetary weather, not as chaos, but as a system where order can emerge in the most unexpected ways. And as Saturn continues its slow orbit around the Sun, this six-sided sentinel keeps watch, a puzzle waiting for the next generation of explorers to decode. Just when astronomers thought they'd catalogued every type of cosmic structure, the universe unveiled another surprise, blinking onto their screens like ghostly halos from the depths of space. They're called odd radio circles, or ORC, and they're some of the most perplexing signals ever detected. Picture faint, glowing rings stretching up to millions of light-years wide, so vast they could engulf entire galaxy clusters, yet emitting nothing but whispers of radio waves. When researchers first spotted them in 2020, the discovery was so unexpected that one team member reportedly asked, "What the hell is this?" What makes ORCs so baffling is their sheer impossibility. These aren't remnants of supernova or the usual radio bursts we've mapped before. They're perfect circles floating in intergalactic space like smoke rings blown by a giant. No visible light, no X-rays, no infrared glow, just these enormous, invisible structures that only reveal themselves in radio frequencies. It's like tuning an old television to static and suddenly seeing crisp, geometric shapes emerge from the noise. Theories, they range from cautiously scientific to wildly speculative. One leading idea suggests ORCs are the shockwaves of gargantuan explosions, perhaps two supermassive black holes colliding billions of years ago, sending ripples through the cosmic fabric. But here's the catch: those shockwaves should have faded by now, leaving no trace. Another proposal points to dark galaxies, hypothetical starless realms where dark matter might generate radio emissions through exotic physics. Then there's the spine-tingling possibility that ORCs are the mouths of wormholes, their gravitational lensing bending radio waves into circular mirages. But the real stumper is their uniformity. ORCs aren't scattered randomly. They appear preferentially near massive elliptical galaxies, as if they're cosmic accessories dangling from galactic belts. Some even have galaxies perfectly centered inside them, like pearls in a loop of string. This precision hints at an underlying order, a pattern we're just not seeing yet. Could they be markers of something far stranger, like fractures in space-time or echoes from a previous universe? For now, every new ORC discovered deepens the mystery. They're reminders that even our most advanced telescopes are still scratching the surface, catching glimpses of a universe that refuses to play by the rules. These ghostly circles aren't just anomalies, they're cosmic breadcrumbs, leading us toward discoveries we haven't even begun to imagine. Somewhere beyond the edges of everything we can see, the universe seems to be pulling itself toward something we can't. This isn't just gravity as we know it. This is the dark flow, a mysterious current sweeping entire galaxy clusters in the same direction at staggering speeds. Imagine standing in a river where every leaf, every twig, every drop of water is being dragged downstream, except the river is the fabric of spacetime itself, and the current is flowing towards something outside our cosmic horizon. The discovery came in 2008 when astronomers studying galaxy clusters noticed something unsettling. These massive structures, each containing thousands of galaxies, weren't just drifting randomly, they were all moving in concert, as if tugged by an invisible hand. The numbers defy logic, clusters millions of light-years apart, racing toward the same patch of sky at over 3 million kilometers per hour. And here's the kicker: there's nothing there to justify the motion. No supercluster, no dense knot of dark matter, no known gravitational source. It's like watching compass needles all point toward a magnet that shouldn't exist. So what's behind this cosmic tug of war? One spine-tingling theory suggests the dark flow might be evidence of a neighboring universe. Picture our cosmos as a bubble floating in an endless foam of other bubble universes, each with its own physics, its own laws. If one of those bubbles brushed against ours in the distant past, its gravitational influence could still be yanking at everything within our observable reach. It's a radical idea, proof of the multiverse written in the motion of galaxies. but skeptics offer alternatives. Could it be the remnant of a primordial imbalance, a lopsidedness baked into the universe during the Big Bang? Or perhaps an error in our measurements, a trick of light or cosmic dust? Yet the data holds up. Even after accounting for every known force, the dark flow persists, its direction eerily aligned with a region of space where the cosmic microwave background, the afterglow of the Big Bang, shows strange temperature fluctuations. That's no coincidence. The implications are staggering. If the dark flow is real, it means our universe isn't just expanding, it's being dragged towards something unimaginable. A structure so vast it lies beyond the cosmic light barrier, a place where the rules of physics might be unrecognizable. It's a humbling thought. Everything we've ever observed, every galaxy, every star, every atom, might just be a speck caught in a current we're only beginning to sense. The dark flow isn't just a mystery, it's a compass pointing toward the ultimate unknown. On the night of August 15, 1977, a radio telescope in Ohio picked up a signal so extraordinary that the astronomer who discovered it scrawled a single word on the printout: "Wow." For 72 seconds, a narrowband radio burst 20 times stronger than the cosmic background noise blared from the constellation Sagittarius. Then, just as abruptly as it began, it vanished. Decades later, that fleeting blip remains one of the most tantalizing mysteries in astronomy. A signal that fits exactly the profile of an interstellar broadcast, yet one we've never been able to explain or replicate. What makes the WOW signal so electrifying is its specificity. It wasn't static or interference, it was a focused, powerful transmission at precisely 1,420 MHz, a frequency known as the hydrogen line. Why does that matter? Because hydrogen is the most abundant element in the universe, and scientists have long theorized that any advanced civilization might use this frequency as a cosmic hello, a natural channel for communication. The signal's intensity spiked and faded exactly as you'd expect if it came from a distant source rotating into and out of the telescope's view. It was too perfect. Yet despite 40 years of searching using telescopes far more advanced than the one that first detected it, we've never heard anything like it again. Not a whisper, not an echo, the silence is deafening. Some argue it must have been a natural phenomenon, like a comet's hydrogen cloud reflecting sunlight or a bizarrely focused burst of cosmic plasma. But here's the catch. Comets don't emit narrowband radio waves, and no known astrophysical event produces such a clean, artificial-looking signal. Every proposed natural explanation crumbles under scrutiny, leaving us with an unsettling void where answers should be. Then there's the chilling possibility that it was artificial, a fleeting message from a civilization far beyond our own. Imagine a beacon turned toward Earth for just over a minute, then deliberately or accidentally switched off. Or perhaps it wasn't meant for us at all, but a cosmic wrong number, a signal intended for someone else that briefly brushed past our antennas, the WOW. Signal's greatest power isn't just its mystery, it's the way it forces us to confront how alone we might truly be in the universe. If it was a greeting, why has no one called back? Astronomers haven't given up. New projects like the Breakthrough Listen initiative scan thousands of stars weekly, hunting for another whisper in the dark. But for now, the WOW signal stands as a cosmic Rorschach test, a blank screen onto which we project our hopes, fears, and deepest questions about whether we're truly alone. It's a 72-second enigma that refuses to fade, a reminder that sometimes the most profound mysteries aren't in the distant stars, but in the silence between them. In the constellation Monoceros, 700 light-years from Earth, a dying star has wrapped itself in one of the most peculiar shrouds ever seen, the Red Rectangle Nebula. This isn't your typical cosmic cloud of gas and dust. Instead, it's a near-perfect geometric spectacle, with vibrant red spokes radiating outward like a celestial spiderweb, all framed by an unmistakable X-shaped structure. It looks less like a natural formation and more like an abstract painting suspended in the void. What makes this nebula so extraordinary is the precision of its shape. Most planetary nebulae, the glowing shells ejected by aging stars, are messy, asymmetrical affairs, blooming outward in chaotic bubbles or spirals, but the red rectangle defies convention. Its lattice-like patterns and razor-sharp angles suggest forces at work that we've never observed elsewhere in the universe. At its heart lies HD 44179, a binary star system where one star has already begun its death throes, shedding layers of material into space. Normally, such ejections would form a rough sphere or disk. Here, though, the expelled gas and dust have arranged themselves into a series of concentric rectangles, as if guided by an invisible hand. The leading theory involves the unique dance of the two central stars. As one star sheds material, its companion's gravity might sculpt that outflow into these bizarre, angular shapes. Think of it like two sprinklers spinning in opposite directions, their water jets colliding to create intricate geometric patterns in midair, but even this explanation falls short. Computer simulations struggle to replicate the nebula's exact structure, particularly the way its red ladder rungs glow with such eerie uniformity. Then there's the color, a deep, blood-red hue unlike anything seen in similar nebulae. This comes from a rare form of carbon molecules called polycyclic aromatic hydrocarbons, which fluoresce under starlight. But why here? Why in such abundance? Some researchers speculate the red rectangle might be a cosmic factory for these complex organic compounds, churning out the building blocks of life in its final act. Perhaps the most haunting question is whether this is a fleeting masterpiece. The nebula's structure is so delicate, so finely balanced, that even subtle changes in the star's orbits could unravel it within millennia, a blink in cosmic time. For now, the red rectangle remains a testament to the universe's capacity for artistry, a reminder that even in death, stars can create beauty beyond our wildest imaginings. And somewhere out there, other dying stars might be weaving their own impossible geometries, waiting for us to find them. High above our planet, drifting silently against the black backdrop of space, an object whispers secrets we still can't decipher. Meet the Black Knight satellite, a name that sounds ripped from a sci-fi thriller, but one that's fueled real-world intrigue for decades. Officially dismissed as space debris, this enigmatic artifact has become the stuff of legend, wrapped in layers of conspiracy, mystique, and eerie radio transmissions that defy easy explanation. The story begins in the late 1950s when amateur radio operators first picked up strange, repeating signals, slow, rhythmic pulses unlike any natural cosmic noise. Then, in 1960, newspapers reported that the U.S. Navy had detected a dark, unidentified object in polar orbit, something not launched by any known nation. By the time declassified documents mentioned anomalous echoes on radar, the mythos was already taking shape, an ancient alien probe silently circling Earth, watching. But what makes the Black Knight so enduring? For starters, its alleged orbit defies conventional physics. Most satellites, even modern ones, follow predictable paths, but eyewitness accounts place this object in a polar orbit, a trajectory considered nearly impossible for human technology at the time. Then there are the photographs, grainy, black and white NASA images from the 1990s showing a jagged, asymmetrical shape trailing the space shuttle. Skeptics argue it's likely a thermal blanket lost during a mission, yet the structure's uneven edges and strange geometry don't quite match. The most tantalizing clues, though, come from the signals. In 1973, Scottish astronomer Duncan Lunan made headlines when he claimed to have decoded one of the early radio bursts, translating it into a star map pointing toward Epsilon Boötes, a star system 13,000 light-years away. His interpretation, a message broadcast millennia ago from a civilization desperate to make contact. While Lunan later retracted his findings, citing flawed data, the idea stuck, a ghostly hand reaching out from the void. NASA insists the Black Knight is nothing more than space junk, perhaps a remnant from early satellite launches or discarded rocket parts. But conspiracy theorists point to inconsistencies. Why has no one definitively identified it? Why do signals still occasionally ping from orbits where nothing should be transmitting? And why, in 2015, did live footage from the International Space Station suddenly cut away as a dark, irregular object drifted into frame? Whether extraterrestrial artifact or cosmic coincidence, the Black Knight endures because it taps into something primal, the fear that we're not alone, and the thrill that something somewhere might be watching back. It's a reminder that even in our own celestial backyard, mystery lingers just beyond the reach of our understanding, waiting for the next chapter to be written. Among the countless stars in our galaxy, one flickers with such erratic behavior that it's earned the nickname, the most mysterious star in the universe. Tabby star, officially catalogued as KIC 8462852, doesn't just dim and brighten predictably like most stars. It plunges into dramatic, irregular dips in brightness, sometimes by as much as 22%. That's the equivalent of a dozen Jupiter-sized planets passing in front of it simultaneously, except there's no planetary formation large enough to explain it. The star's bizarre light patterns have sparked everything from cautious scientific theories to wild speculation, including the tantalizing possibility that we're witnessing something never seen before, an alien megastructure at work. When astronomer Tabitha Boyajian first spotted the anomalies in data from the Kepler Space Telescope in 2015, the readings defied all conventional explanations. Planets too large, dust clouds too inconsistent, even a swarm of comets, one early hypothesis, couldn't account for the star's extreme and irregular dimming. The data looked less like natural astrophysics and more like something was deliberately blocking the star's light in unpredictable, jagged patterns. That's when researchers at the SETI Institute raised the stakes. Could this be evidence of a Dyson sphere, a hypothetical alien megastructure designed to harness a star's energy? Imagine a civilization so advanced it builds a colossal network of solar panels or mirrors encircling its home star, capturing every drop of energy. That's the concept behind a Dyson sphere, a thought experiment first proposed by physicist Freeman Dyson in the 1960s. While the idea sounds like science fiction, Tabby's star's behavior fits some of the expected signatures: sporadic, unnatural dimming as sections of the structure rotate into view. The notion sent shockwaves through the astronomy community, not because anyone claimed proof of aliens, but because for the first time we had data strange enough to consider it. But before we jump to extraterrestrial conclusions, there's another side to the story. Further observations revealed the star also dims unevenly across different wavelengths, a clue that points toward cosmic dust. Unlike a solid megastructure which would block all light uniformly, dust scatters certain wavelengths more than others, creating a murky, color-dependent dimming effect. By 2018, new studies showed the star fading more in ultraviolet than infrared, a smoking gun for fine particles drifting between us and the star. Yet even this explanation leaves gaps. Why does the dust behave so erratically? Why are the dimming events so clustered in time, as if the star is being shrouded in fits and starts? Then there's the star's long-term fading, a separate mystery altogether. Over the past century, Tabby's star has inexplicably lost about 14% of its brightness, a decline no known stellar behavior can fully account for. Some researchers propose a catastrophic collision of planets or a recent engulfment of a gas giant, events that could litter the star's vicinity with debris. Others wonder if we're seeing the aftermath of a cosmic snowplow, where gravity from an unseen companion star herds comets into dense, light-blocking swarms. For now, Tabby's star remains an open case, a celestial riddle that refuses to surrender its secrets. It's a reminder that the universe doesn't need aliens to astonish us. Natural phenomena can be just as baffling. But it's also a beacon of possibility, a hint that somewhere out there, answers might be waiting that could rewrite our understanding of stars, civilizations, and everything in between. Whether dust or Dyson sphere, this star's flickers are more than just anomalies. They're flashes of the unknown, daring us to look closer. Picture the universe not as a scattering of isolated galaxies, but as an unfathomably vast spiderweb, one where every silken thread connects bustling cities of stars in an intricate celestial network. This is the cosmic web, the hidden skeleton of reality itself. Stretching billions of light years across the observable universe, it's a labyrinth of glowing filaments, dense galaxy clusters, and yawning voids, all woven together by the invisible threads of dark matter. And here's the kicker: this isn't just background scenery. It's the blueprint of existence, the scaffolding that shapes everything we see. Yet how it formed remains one of cosmology's greatest unsolved riddles. For decades, astronomers assumed galaxies were distributed randomly like flour tossed across a counter. But as telescopes grew more powerful, a startling pattern emerged. Galaxies weren't scattered at all. They clung to shimmering tendrils of hydrogen gas and dark matter, forming a web so vast that individual strands can stretch for 500 million light-years. At the intersections of these filaments sit the universe's metropolises, colossal galaxy clusters, each containing thousands of Milky Ways between them. The void's caverns of near-nothingness, so empty they distort our perception of space itself. The real magic lies in the web's construction. According to supercomputer simulations, this cosmic lattice began as microscopic quantum fluctuations in the fiery aftermath of the Big Bang. Over billions of years, gravity amplified those tiny ripples, pulling dark matter into vast, thread-like structures. Ordinary matter, the stuff of stars and planets, then followed these dark matter highways, pooling into galaxies along the filaments like dew on a spider's silk. But the simulations only get us so far. Why do some filaments appear perfectly straight, while others twist into bizarre knots? Why do certain voids remain utterly barren, while others harbor rogue galaxies drifting like lone ships in the dark? Even more perplexing is the web's transparency. Most of its structure is made of ionized hydrogen, so diffuse it's nearly invisible. Until recently, we could only infer its presence by mapping galaxy positions. Then in 2021, the Keck Cosmic Web Imager captured the first direct images of these filaments, revealing them glowing faintly with the ultraviolet light of ancient quasars. It was like turning on a blacklight in a cosmic basement, illuminating cobwebs we never knew were there. But the grandest question remains unanswered: what controls the web? Dark matter's gravity sets the stage, but other forces like the mysterious dark energy accelerating the universe's expansion are stretching and warping the web's structure in ways we can't yet predict. Some filaments seem to be evaporating, their galaxies pulled apart by cosmic expansion, while others grow denser, as if the universe is tightening its own stitches. Perhaps the most humbling thought is this: we're not just observers of the cosmic web, we're part of it. The Milky Way resides on a minor filament, a suburban branch of the Laniakea supercluster. Every atom in our bodies, every star in our sky, exists because this invisible architecture funneled matter into the right places at the right time. The web isn't just out there, it's the reason we're here. And as we peel back its layers, we're not just mapping the universe, we're reading our own origin story, written in threads of light and shadow. Rising from the heart of the Eagle Nebula like a celestial cathedral, the pillars of creation stand as one of the most breathtaking sights in the cosmos. These towering columns of gas and dust, immortalized by the Hubble Space Telescope in 1995, stretch over 4 light-years high, enough to span the distance from our Sun to its nearest stellar neighbor. But their grandeur isn't what makes them impossible. It's the fact they shouldn't be here at all. Bathed in the relentless radiation of nearby massive stars, these pillars exist in a cosmic demolition zone. Imagine a sandcastle holding its shape against a hurricane. That's the level of defiance we're talking about. Ultraviolet light from these stars is so intense it should have shredded the pillars into stardust eons ago. Yet somehow they've endured for thousands of years, their intricate tendrils and knotted protrusions still intact. The secret lies in their own self-destruction. As the outer layers evaporate under the stellar onslaught, they create a protective barrier of dense gas, shielding the inner regions like a cosmic force field. It's a stellar paradox. The very process that should erase them is what keeps them standing, but the real magic happens inside. These pillars aren't just survivors, they're stellar nurseries. Nestled within their dense cores are fledgling stars, their birth ignited by the same radiation that threatens to tear the pillars apart. Hubble's infrared vision has peered through the dust, revealing newborn stars flickering to life like fireflies in a smoky room. Some are so young they're still swaddled in cocoons of gas, while others have begun blowing bubbles in the surrounding material, carving out their own space in the universe. Then there's the haunting twist. We might be looking at a ghost. Some astronomers suggest the pillars could already be gone, vaporized by a supernova shockwave 6,000 years ago. Because light takes time to travel, their destruction wouldn't be visible from Earth for centuries. It's a chilling thought that one of the universe's most iconic structures might only exist as an echo, a cosmic photograph of something long vanished. Yet even if the pillars fade, their legacy won't. Every star born within them carries their story forward, a testament to the universe's relentless cycle of creation and destruction. They remind us that beauty and violence are often intertwined, and that sometimes the most fragile things endure against all odds. The pillars of creation aren't just a spectacle, they're a cosmic lesson in resilience, written in gas and starlight. Hidden in the afterglow of the Big Bang itself lies a cosmic anomaly so bizarre it might just rewrite our understanding of reality. The CMB Cold Spot, a chilling void in the cosmic microwave background, stretches nearly 2 billion light-years across, a frozen bruise on the universe's oldest light. Temperatures here plunge mysteriously lower than their surroundings, as if some unseen force reached into the fabric of space-time and siphoned away its heat. This isn't just a statistical fluke, it's a gaping discrepancy that defies our models of cosmic evolution. When scientists first mapped the cosmic microwave background, the faint echo of the universe's birth, they expected subtle, random variations. But the cold spot stood out like an iceberg in a desert. Probability calculations suggest there's less than a 2% chance such a feature could form naturally. So what carved this frigid gash into the early universe? One spine-tingling hypothesis suggests we're seeing the imprint of a collision with another universe. Picture our cosmos as a bubble floating in an endless multiverse foam. If another bubble brushed against ours during the Big Bang's aftermath, the energy drained from that contact could have left this cosmic cold sore, a scar from a reality beyond our own. But not everyone's ready to jump to parallel universes. Skeptics point to the Great Void theory, an attempt to explain the cold spot as the shadow of an unfathomably large, empty region of space. If a supervoid lies between us and the cold spot, its lack of matter could subtly redshift the CMB light passing through, creating the illusion of a temperature drop. There's just one problem. Surveys can't find a void large or empty enough to match the cold spot's staggering scale. The few candidate voids discovered are like using a thimble to explain the Grand Canyon, nowhere near sufficient to account for the anomaly. Then there's the strangest twist of all. The cold spot isn't just cold, it's structured. Detailed maps reveal concentric rings of temperature variation within it, patterns that resemble ripples from a pebble dropped in a pond. Such complexity shouldn't exist in a random fluctuation. Some theorists speculate these ripples could be evidence of cosmic textures, exotic defects in space-time left over from the universe's violent birth. These hypothetical knots in reality's fabric would warp space around them, leaving telltale imprints in the CMB. Whether gateway to another reality or fossil from our own universe's birth pangs, the cold spot forces us to confront how much we still don't understand about the cosmos. It's a reminder that even our most comprehensive snapshots of reality, like the pristine CMB, might be hiding secrets in plain sight. And as telescopes probe deeper, this icy enigma remains a beacon, drawing us toward discoveries that could shatter or redefine everything we think we know. Imagine a world where the ground beneath your feet isn't rock or sand, but diamond. Not just a few scattered gems, but an entire planet crusted in the stuff, glittering under the light of its nearby star. This isn't science fiction, it's 55 Cancri E, one of the most baffling exoplanets ever discovered. Dubbed the Diamond Planet, this celestial jewel orbits so close to its sun that a single year lasts just 18 hours, and surface temperatures soar above 2,000 degrees Celsius, hot enough to melt steel. But what makes this world truly extraordinary isn't just its scorching climate. It's the fact that scientists believe it's literally made of crystallized carbon, a diamond-covered enigma that defies everything we thought we knew about how planets form. The story begins with the planet's composition. Most rocky worlds, like Earth, are rich in oxygen and silicon, with carbon playing a minor role, but 55 Cancri E is different. Spectroscopic readings suggest its host star contains unusually high levels of carbon, a clue that the planet itself might be a carbon-rich oddity. Under the crushing pressures of its super-dense core, that carbon could have crystallized into diamond, creating a mantle hundreds of kilometers thick. Picture a planetary core wrapped in a diamond shell, its surface possibly studded with graphite mountains and molten carbon lakes. It's a geologist's dream and a planetary scientist's nightmare, because nothing in our solar system prepares us for this. Then there's the puzzle of its origin. How does a diamond planet even form? One theory suggests it might be the corpse of a gas giant, its outer layers of hydrogen and helium stripped away by the star's relentless radiation, leaving behind a carbon-heavy core. Another proposes it was born in a protoplanetary disk unusually rich in carbon, where carbon grains clumped together instead of silicates, but neither explanation fully accounts for the planet's staggering density, almost twice that of Earth, or its bizarre orbital dance. 55 Cancri E doesn't just orbit its star, it's tidally locked, with one face permanently scorched and the other locked in endless night. But the real kicker: the diamonds might not even be the strangest part. Recent observations hint that the planet could have an atmosphere, a thin, volatile shroud of vaporized rock and gases like hydrogen cyanide. If true, it would mean this diamond world is capped by poisonous skies, a toxic veil swirling over a glittering wasteland. Some researchers even speculate that under such extreme pressures, the carbon might exist in exotic forms we've never seen, perhaps even a super-dense carbon metal with bizarre electrical properties. The Diamond Planet forces us to rethink the recipe for planetary diversity. If worlds like this can exist, what other impossibilities are waiting in the cosmos? It's a reminder that the universe doesn't just defy expectations, it shatters them, leaving us to piece together the fragments of what we thought we knew. And somewhere out there, 55 Cancri glitters in the darkness, a cosmic jewel box daring us to unlock its secrets. At the heart of the Virgo cluster, a cosmic predator lurks, Messier 87, a galaxy with an insatiable hunger. This isn't just any supermassive black hole. It's a gravitational behemoth weighing in at 6.5 billion times the mass of our Sun, with an appetite so relentless it's earned the nickname the Cannibal Galaxy. But what makes M87 truly terrifying isn't just its size, it's the way it feasts. While most black holes consume matter quietly, this one devours stars with a violent flare, belching out jets of superheated plasma that stretch 5,000 light-years into the void. The first direct image of M87's event horizon, captured in 2019 by the Event Horizon Telescope, was a triumph of science, a smoking gun proof of Einstein's century-old predictions about black holes. That glowing ring of light, bent by gravity so intense it warps spacetime itself, matched his equations to perfection. But the photo also revealed something unsettling. The black hole's shadow was lopsided, a sign of chaotic, uneven feeding. Like watching a messy eater at a cosmic buffet, we're seeing matter swirl in at odd angles, some swallowed whole, some spat back out in those terrifying jets. Speaking of jets, these aren't just cosmic exhaust pipes. They're particle accelerators on a galactic scale, shooting matter at 99% the speed of light. The energy required to launch these beams is mind-boggling. Each jet pumps out enough power to outshine the entire Milky Way. And here's the mystery. No one knows exactly how the black hole's magnetic fields twist and channel this energy so efficiently. It's like trying to explain how a hurricane can focus its winds into a laser beam. But the real enigma is M87's dining habits. Most supermassive black holes snack intermittently, their meals dictated by chance encounters with passing gas clouds or stars. This one, though, seems to be on a perpetual binge. Astronomers have detected entire stars being ripped apart in its grasp, their materials stretched into spaghetti-like streams before vanishing into the abyss. Some theories suggest M87 might be eating for two, fueling not just the black hole, but an invisible companion, like a second black hole locked in a gravitational dance. Others wonder if its location at the center of a galaxy cluster gives it an unfair advantage, funneling a non-stop supply of cosmic prey into its maw. Then there's the fallout. Those plasma jets aren't just spectacular light shows, they're shaping the destiny of an entire galaxy. By blasting energy outward, they prevent gas from cooling and forming new stars, effectively sterilizing M87's future. It's a cosmic catch-22. The black hole's growth stifles the very galaxy that birthed it. Yet for all its destructive power, M87 might hold the key to understanding how black holes and galaxies evolve together. Its violent jets could be seeding the intergalactic medium with heavy elements, scattering the building blocks of future stars and planets far beyond its borders. Even as it devours, it gives back a reminder that in the cosmos, death and creation are often two sides of the same coin. The Cannibal Galaxy isn't just a monster, it's a cosmic architect sculpting the universe in ways we're only beginning to comprehend. J1407b isn't just another exoplanet, it's a cosmic hall of mirrors, a world so utterly alien that it makes Saturn's iconic rings look like child's play. Dubbed Super Saturn, this distant giant boasts a ring system 200 times wider than Saturn's, stretching over 180 million kilometers from edge to edge. To put that in perspective, if J1407b replaced Saturn in our solar system, its rings would dominate Earth's night sky, appearing larger than a full moon and casting eerie shadows across the landscape. But here's the twist: such an extravagant ring system shouldn't exist, not just because of its scale, but because physics says it should have collapsed into moons eons ago. The discovery traces back to 2012, when astronomers noticed something bizarre in the light curve of a young star called J1407. Every few years, the star's brightness would dip in erratic, jagged patterns, not the clean, symmetrical dimming caused by an orbiting planet, but a chaotic series of spikes and troughs. After ruling out instrument errors and stellar activity, the culprit became clear: a monster ring system, so complex it contains over 30 distinct rings, each separated by gaps as cleanly defined as the Cassini division in Saturn's own rings. The sheer amount of material in these rings is staggering enough to build several Earth-sized moons, yet they persist, defying every model of planetary ring evolution. What makes J1407b's rings so baffling is their youth. The planet orbits a star barely 16 million years old, a cosmic toddler compared to our 4.5 billion-year-old Sun. In such a young system, conventional wisdom says rings should still be clumping together under gravity, coalescing into moons. Instead, J1407b's rings remain stubbornly fragmented, their intricate structure preserved like a snapshot of chaos frozen in time. Some theorists suggest the planet might be shepherding the rings with unseen exomoons, their gravitational nudges preventing the debris from collapsing. Others propose the rings are the aftermath of a recent cataclysm, perhaps a moon torn apart by tidal forces, its fragments now suspended in a delicate dance between gravity and centrifugal force. Then there's the shadow play. The gaps in J1407b's rings aren't empty, they're sculpted by something. When researchers modeled the system, they found that at least one of these gaps likely harbors an Earth-sized moon in the making, a proto-world caught in the act of formation. If confirmed, it would offer a rare glimpse into how moons are born from rings, a process we've only theorized about in our own solar system. But even this moon can't fully explain the ring's extreme scale. Something else is at work here, maybe a resonance with the planet's magnetic field, or interactions with a dusty circumplanetary disk we can't yet detect. The most tantalizing question isn't just how these rings exist, but for how long. Ring systems are fleeting cosmic phenomena. Saturn's famous bands may vanish in another 100 million years. Yet J1407b's rings, for all their fragility, seem locked in some perfect equilibrium, as if the planet found a way to cheat time itself. Whether they're a fleeting spectacle or a new class of stable structure, one thing's certain: this Super Saturn has rewritten the playbook on what's possible in planetary science. And somewhere out there, other ringed giants might be waiting, each one a clue to the untold diversity of worlds hidden in the darkness. In the year 1572, astronomer Tycho looked up at the night sky and saw the impossible, a new star blazing brighter than Jupiter where no star should be. This was no ordinary celestial light. It was a supernova, the violent death throes of a star exploding with the force of 100 billion suns. Yet 4 centuries later, scientists made an even more shocking discovery. Somehow, against all cosmic logic, the star that created Tycho's supernova didn't die. It's still there, a cosmic zombie that refused to stay dead. This stellar survivor, officially known as Tycho G, hides in the wreckage of its own destruction. Most supernovae leave behind either a dense neutron star or a black hole, the collapsed cores of their former selves. But Tycho G is different. It's a normal, hydrogen-burning star, still shining quietly in the aftermath of what should have been its final act. Imagine setting off a nuclear bomb in your living room, only to find your favorite houseplant still thriving in the crater. That's the level of defiance we're dealing with here. So how did this star cheat death? The leading theory is as bizarre as the phenomenon itself. Tycho G might have been the unlucky companion in a two-star system, orbiting a white dwarf that stole its hydrogen until it became unstable and detonated. In this scenario, the explosion would have blasted most of the white dwarf into space while somehow sparing its partner, like a grenade going off in someone's hand, but leaving their wedding ring unscathed. Yet even this explanation strains credibility. The energy released by a Type Ia supernova, the kind Tycho's star produced, is enough to vaporize nearby worlds. For a star to survive at such close range, it would have needed to be both extraordinarily dense and cosmically lucky. Then there's the mystery of its speed. Tycho G isn't just sitting quietly in the debris field. It's racing away from the supernova remnant at breakneck velocity, as if kicked by the explosion's shockwave. Measurements suggest it's moving 3 times faster than typical stars in its region, a telltale sign of violent trauma. Some astronomers argue this proves it was indeed the companion star, flung outward like a pebble from a slingshot. Others counter that its chemical composition doesn't quite match what you'd expect from a star that donated mass to a white dwarf. The debate rages on, with each new observation adding twists to the tale. Perhaps the most haunting possibility is that Tycho G isn't unique, that stellar zombies might be more common than we thought. Recent surveys have uncovered other candidates, stars lingering improbably in supernova remnants, their survival challenging our models of stellar death. If these cosmic phoenixes can rise from their own ashes, what else have we gotten wrong about how stars live and die? Tycho's zombie star isn't just a curiosity. It's a crack in the foundation of astrophysics, a reminder that even the most violent events in the universe might leave survivors we never imagined possible. And somewhere out there, other stars might be waiting to reveal their own secrets of cheating death. Most galaxies shine with the light of billions of stars, their spirals and halos painted across the cosmos in brilliant swirls. But Dragonfly 44 is different. This shadowy enigma lurking in the Coma cluster 330 million light-years away is a ghost, a galaxy made almost entirely of dark matter. If typical galaxies are bustling cities, Dragonfly 44 is an empty skyscraper, its halls nearly vacant, its structure held up by something we can't see. Discovered in 2016 by the Dragonfly Telephoto Array, a telescope purpose built to spot ultra-dim objects, this galaxy emits just 1% of the light expected for its size. Yet its stars move at dizzying speeds, orbiting so fast that without some invisible anchor, the galaxy should have torn itself apart long ago. The math reveals the truth. Dragonfly 44 is 99.99% dark matter, a cosmic husk where the unseen outweighs the seen by a factor of 10,000. It's as if we've stumbled upon a celestial puppet, its visible stars mere strings manipulated by an unseen hand. What makes this discovery so unsettling isn't just the galaxy's darkness, it's what it implies about the universe. For decades, dark matter was thought to play a supporting role, a gravitational glue holding galaxies together. But Dragonfly 44 suggests the opposite, that dark matter might be the architect, building frameworks where ordinary matter is little more than decoration. Imagine finding a towering castle where every brick is invisible, with only a handful of visible flags fluttering atop its walls. That's the level of inversion we're dealing with here. Theories about how such a galaxy formed range from the plausible to the extraordinary. One camp argues it's a failed galaxy, born in a pocket of the early universe where gas for star formation was scarce, leaving dark matter to dominate. Others propose it's the remnant of a violent encounter, its stars stripped away by a passing galaxy's gravity, leaving only its dark matter skeleton behind. But the most tantalizing idea, Dragonfly 44 might not be alone. Surveys have since uncovered other ultra-diffuse galaxies with similar eerie profiles, hinting that dark matter's role in shaping the cosmos might be far more creative and far stranger than we ever imagined. Yet the biggest question remains unanswered. What is dark matter doing here? If it can assemble entire galaxies with almost no stars, what else is it capable of? Could there be galaxies made entirely of dark matter, floating unseen in the void? Dragonfly 44 doesn't just challenge our understanding of galaxies, it forces us to reconsider the very fabric of reality, where the invisible might be the true sculptor of the universe. And somewhere in the darkness, other shadowy giants might be waiting, their secrets written in the silence between the stars. Nestled in the constellation Libra, a faint yellow star flickers with a secret that nearly upended modern cosmology. HD 140283, better known as the Methuselah star, holds the record as the oldest known star in the universe, but when scientists first calculated its age, they got a result so shocking it sent them scrambling back to their equations. 14.5 billion years old, that's the number that appeared on their screens, a figure older than the universe itself by nearly 1 billion years. For a brief, dizzying moment, it seemed science had stumbled upon something impossible, a star that existed before time began. The discovery sent shockwaves through the astronomy community. How could a star predate the cosmos that birthed it? The answer lies in the delicate art of stellar archaeology. Unlike most stars, which are contaminated by heavier elements from previous generations, the Methuselah star is a metal-poor relic from the universe's infancy, a pristine time capsule with barely any elements heavier than hydrogen and helium in its atmosphere. By measuring its brightness, temperature, and composition, astronomers can trace its origins back to just a few 100 million years after the Big Bang. But those early calculations came with a glaring problem: margin of error. Estimating stellar ages is like trying to guess a tree's lifespan by examining a single ring. The slightest miscalibration can lead to absurd results. Revised measurements using updated parallax data from the Gaia satellite eventually brought the star's age down to a slightly less paradoxical 13.5 billion years, still ancient, but now safely younger than the universe's 13.8 billion year timeline. Yet the mystery didn't end there. Even with the correction, the Methuselah star remains bafflingly old, pushing the limits of how soon stars could have formed after the Big Bang. Current models suggest the first stars ignited around 100 million years after cosmic dawn, but this one appears to have flickered to life shockingly early, as if the universe hit the ground running. What makes this star so extraordinary isn't just its age, but its survival. Most primordial stars were behemoths, burning hot and dying young in spectacular supernova. The Methuselah star, though, is a modest subgiant about 80% the mass of our Sun, meaning it's been sipping its nuclear fuel frugally for eons. Its longevity offers a rare window into conditions just after the Big Bang, when the first starlight pierced the cosmic dark. Traces of lithium in its atmosphere, an element typically destroyed in stellar cores, might even preserve chemical fingerprints from the universe's very first moments. But the most tantalizing question remains: are there others like it? If one star defied expectations by forming so early, could there be an entire population hiding in plain sight, rewriting the timeline of cosmic dawn? The Methuselah star stands as both a triumph and a challenge, a reminder that even our most precise calculations are only as good as the assumptions we feed them. And somewhere out there, other ancient sentinels might be waiting, their faint light carrying stories from a time before time as we know it. Deep in the ice of Antarctica, scientists have built one of the strangest telescopes on Earth, not to capture light but to catch shadows. The Ice Cube Neutrino Observatory doesn't look like your typical telescope. Instead of lenses and mirrors, it's a grid of sensors buried under a kilometer of polar ice, waiting for flashes of blue light that betray the passage of the universe's most elusive particles, neutrinos. These ghostly particles, so small they can pass through light years of lead without a single collision, might be the key to unlocking cosmic secrets hidden in plain sight. But in 2022, something extraordinary happened. IceCube detected a barrage of high-energy neutrinos unlike anything we've seen before, blobs of energy streaming from deep space with no identifiable source. It was like finding footprints in the snow, but no sign of whatever left them behind. Neutrinos are nature's ultimate ghosts, born in the hearts of exploding stars, black hole jets, and other violent cosmic events. They zip through the universe at near light speed, barely interacting with matter. Trillions pass through your body every second, leaving no trace. But the ones IceCube catches are different, ultra-high-energy messengers packing a punch equivalent to a major league fastball in a particle smaller than an atom. When these rare, energetic neutrinos do collide with an atom in the ice, they create a secondary particle called a muon, which emits a faint blue glow as it streaks through the frozen depths. That's the signal scientists hunt for, a fleeting flash that whispers of distant cosmic cataclysms. The mystery: these recent neutrino blobs don't point back to any known source. Normally, when we detect high-energy neutrinos, we can trace their paths to violent events like active galactic nuclei or gamma-ray bursts, but these arrive like envelopes with no return address. Some seem to originate from empty patches of sky regions where our telescopes see nothing but darkness. Others arrive in clusters, suggesting they might be coming from the same unknown event, yet no corresponding explosion or collision appears in our observations. It's as if the universe is playing a cosmic game of hide and seek, leaving clues but refusing to reveal the players. One spine-tingling possibility is that we're seeing the fingerprints of dark matter. Some theories predict that when these invisible particles collide and annihilate, they could produce bursts of neutrinos. If true, these ghostly blobs might be our first direct window into the dark universe, a shadow realm that makes up 85% of all matter yet remains utterly invisible to us. Alternatively, they could be signals from objects we've never imagined, cosmic factories churning out neutrinos through processes we haven't yet discovered. Or perhaps they're the echoes of events so ancient their light has faded into oblivion, leaving only these faint, nearly massless particles to tell the tale. The hunt is now on to solve this puzzle. New detectors, like the proposed Pacific Ocean neutrino experiment, aim to expand our net for catching these elusive particles. Meanwhile, astronomers are scouring the skies with every tool available, from radio telescopes to gravitational wave observatories, hoping to catch some other hint of what's sending these neutrino blobs our way. Every detection is a breadcrumb, a tiny piece of a story we're only beginning to read. The universe is speaking to us in whispers, and for the first time, we're learning how to listen. These ghostly neutrinos might just be the key to unlocking cosmic mysteries we didn't even know existed. Imagine a cosmic fugitive, a supermassive black hole, billions of times heavier than our Sun, barreling through the void at breakneck speed with no galaxy to call home. These aren't the stationary monsters we're used to, lurking at the centers of galaxies like spiders in a web. These are rogue black holes, cosmic outcasts flung into the abyss by forces so violent they defy comprehension. And what's truly chilling, we have no idea how many of these gravitational renegades are out there, drifting unseen through the darkness. The discovery of these lone wanderers shattered a fundamental assumption that every supermassive black hole sits firmly anchored in a galaxy's heart. The first clues came from bizarre quasars, extremely bright galactic cores floating strangely far from any visible galaxy. Then, in 2012, Hubble spotted a quasar 3.5 billion light-years away, blazing with the energy of 1,000 Milky Ways, yet completely isolated. No galaxy surrounded it, no stars trailed behind it, just a supermassive black hole screaming across the cosmos at over 5 million miles per hour, fast enough to cross the distance from Earth to the Moon in under 3 minutes. How does something so monstrous get kicked out of its home? The leading theory involves a cosmic game of gravitational pinball. When two galaxies collide, their central black holes eventually spiral toward each other, locked in a deadly dance. As they merge, the titanic collision warps spacetime itself, ejecting the newborn black hole in a random direction like a watermelon seed squeezed between fingers. Simulations show these recoiling black holes can reach speeds up to 10 million miles per hour, enough to escape even the most massive galaxies' grip. But here's the catch: the energy required is almost unimaginable. We're talking about the equivalent of 100 million supernova channeled into a single, precise kick. Yet the mysteries pile up. Some rogue black holes move too slowly to have been ejected by mergers. Others seem to have been homeless since birth, raising the spine-tingling possibility that they formed directly from collapsing clouds of primordial gas in the early universe, a process we thought impossible for objects this massive. Then there's the eerie case of SDSS Joan 22859 plus 0219305. A black hole drifting between two galaxies as if it were a celestial vagabond pausing between towns. The real terror: these rogues are invisible unless they're actively feeding. A lone black hole, no matter how massive, emits no light. It could be sailing past our cosmic neighborhood right now, warping starlight subtly enough that we'd never noticed until it was too late. Thankfully, the distances are vast, but the implication is clear. The universe might be teeming with dark, hungry giants we've yet to detect. What happens to a galaxy that loses its central black hole? Does it spiral into chaos or live on undisturbed? Could rogue black holes seed new galaxies in the void, their gravity pulling together the first stars of a future empire? Every discovery peels back another layer of this enigma, revealing a cosmos far more dynamic and unpredictable than we ever dreamed. These gravitational nomads aren't just cosmic oddities, they're proof that even the mightiest structures in the universe can be uprooted, set adrift, and forced to wander the infinite dark. At the edge of the observable universe, 3 brilliant beacons burn with the intensity of 1 trillion suns, locked in a gravitational dance so improbable it rewrites the rules of cosmic companionship. This is the Impossible Quasar Trio, a system where not one, not two, but 3 quasars orbit each other in perfect synchrony, the odds of such an alignment existing naturally. Astronomers estimate it's like flipping a coin and getting heads 10,000 times in a row, a statistical nightmare that shouldn't happen even once in the lifetime of the universe. Yet here they are, their searing light piercing 13 billion years of space-time to challenge everything we thought we knew about how these cosmic powerhouses form. Quasars are already extreme by nature supermassive black holes, gorging on so much matter that their accretion disks outshine entire galaxies. But finding 3 in such tight proximity isn't just rare, it's a fundamental contradiction. Current models suggest quasars ignite when galaxies collide, funneling gas toward their central black holes. But for 3 quasars to light up simultaneously within the same system, that would require a near-impossible trifecta of galactic mergers, all happening in the same pocket of space at the same cosmic moment. It's like witnessing 3 volcanoes erupting in sync on 3 neighboring islands, an event so finely tuned it reeks of cosmic orchestration. The discovery, made by the European Southern Observatory's Very Large Telescope, left researchers reeling. Each quasar in the trio blazes with its own distinct signature, proving they're not optical illusions or gravitational mirages. Their separation just 50,000 light-years, a stone's throw in galactic terms, suggests they're bound in a delicate orbital ballet, their paths choreographed by forces we've yet to comprehend. Even more baffling, their light reveals they ignited within 100 million years of each other, a blink in cosmic time. For comparison, our Milky Way hasn't merged with another large galaxy in 10 billion years, and we've never hosted a quasar. Theories scramble to explain this trifecta. One radical idea proposes they're the remnants of a primordial, dark matter halo, an unusually dense knot in the early universe's invisible scaffolding that funneled gas to 3 black holes at once. Others suggest they're the product of a hypermerger, where not 2 but 4 galaxies collided in a chaotic pileup, leaving 3 black holes feasting side by side. But simulations struggle to recreate such a scenario without one quasar being ejected or swallowed. Then there's the lingering question of what happens next. With black holes this massive and this close, their fate is inevitable. A slow-motion spiral into one another, culminating in gravitational waves so powerful they'd ripple across the cosmos. Yet the very existence of this trio suggests such mergers might be more common and more complex than we ever imagined. Could their improbable alignment be a clue that the early universe was far more crowded and violent than our models predict? Or are we glimpsing a rare cosmic fluke, a once-in-a-universe anomaly that, by sheer luck, we're alive to witness? The impossible quasar trio doesn't just defy expectations, it exposes the gaps in our understanding of how structures form in the cosmos. It's a reminder that the universe thrives on outliers, crafting phenomena so extraordinary they force us to rethink the boundaries of physics itself. And somewhere out there, other triple threats might be lurking, their light still traveling toward us, ready to append another assumption we didn't even know we had. At the outermost fringes of our galaxy, where the Milky Way's spiral arms dissolve into the void, something peculiar lurks, a boundary so bizarre it behaves less like a natural structure and more like a cosmic force field. Known as the Galactic Barrier, this invisible frontier marks a zone where high-energy cosmic rays suddenly spike to intensities unmatched anywhere else in the galaxy. It's as if the Milky Way has erected its own version of Earth's Van Allen belts, but on a scale so vast it defies comprehension. The mystery began when spacecraft like Voyager and Pioneer detected an unexpected surge in radiation as they approached the galaxy's edge. Instead of the gradual drop-off scientists anticipated, the particles grew fiercer, like waves crashing against an unseen shore. These aren't just ordinary cosmic rays, they're protons and atomic nuclei accelerated to nearly light speed, packing enough energy to punch through solid lead. Yet here, they seem to pile up, trapped or amplified by forces we can't yet explain. What's fueling this celestial roadblock? One theory suggests it's the work of the galaxy's magnetic field, which might twist and compress near the edges, creating a bottleneck for charged particles. Imagine a river narrowing into rapids, its currents churning violently as they squeeze through a tight gorge. But there's a problem. Our maps of the Milky Way's magnetic field don't show the kind of intensity needed to produce such extreme effects. Another idea ventures into speculative territory that the barrier could be evidence of something beyond our galaxy exerting influence. Some researchers propose it's the shock front of a collision with an ancient, invisible stream of dark matter, its gravitational wake stirring up cosmic rays like leaves in a storm. Others wonder if we're seeing echoes of a long-ago galactic encounter where a smaller galaxy brushed past the Milky Way, leaving this turbulent imprint in its wake. Then there's the most tantalizing hypothesis that the barrier isn't an accident at all, but a shield. If an advanced civilization wanted to protect itself from extragalactic radiation or even curious neighbors, manipulating magnetic fields on a galactic scale might be the ultimate defense. While this leans into science fiction, it raises a provocative question. Could natural processes alone create such a precise, energetic boundary, or is the universe capable of engineering structures we've yet to imagine? For now, the galactic barrier remains one of the Milky Way's most confounding riddles. It challenges our assumptions about how galaxies interact with the space around them, and whether there's more to cosmic boundaries than mere emptiness. Every new probe we send toward the edge brings back data that deepens the mystery, hinting that our galaxy's outer limits might be anything but quiet. The barrier isn't just a scientific curiosity, it's a frontier, daring us to look beyond and question what else might be hiding in the shadows of the cosmic map. Most stars that go supernova don't live to tell the tale. They explode with such violence that nothing remains but scattered debris. But LP 4365 is different. This cosmic fugitive didn't just survive its own destruction. It rocketed away from the scene at over 5 million kilometers per hour, leaving astronomers stunned. Dubbed the Runaway Supernova, this stellar survivor is rewriting the rules of how stars die and what happens when death doesn't stick. What makes this star so extraordinary is its speed. Most stars drift lazily through the galaxy at a few 100,000 kilometers per hour. LP 4365, it's moving fast enough to cross the distance from Earth to the Moon in under 4 minutes. That kind of velocity doesn't happen by accident. Something unimaginably powerful kicked this star like a cosmic pebble, sending it careening through the void. The leading theory, it was the victim of a failed supernova, an explosion so lopsided that it blasted the star clear of the blast zone instead of obliterating it entirely. But the real puzzle lies in its composition. When astronomers analyzed its light, they found something bizarre. LP 4365 is made almost entirely of heavy metals, neon, oxygen, magnesium, with barely a trace of hydrogen or helium, the usual building blocks of stars. It's like finding a car engine running on pure gold instead of gasoline. This bizarre chemistry suggests the star wasn't just a bystander to its own supernova, it was torn apart from the inside out. Here's how it might have happened. LP 4365 was once part of a binary system orbiting a white dwarf companion. Over time, the white dwarf siphoned material from its partner, growing unstable until it detonated as a Type I supernova. But instead of consuming both stars, the explosion might have been asymmetrical, a cosmic grenade with a weak spot that sent one half of the system hurtling into space while the other was vaporized. The surviving star, scorched and stripped of its outer layers, would have been left as a bare metallic core flung outward like shrapnel. Yet even this explanation doesn't account for everything. The star's trajectory is too straight, too precise, as if it was launched from a cosmic railgun. Some models suggest the explosion might have been turbocharged by exotic physics. perhaps a runaway nuclear reaction deep in the white dwarf's core, or even the influence of a third, unseen star that altered the blast's dynamics. Others speculate that LP 4365 might be something even rarer, a zombie star, a remnant that briefly reignited after the supernova before being ejected. The implications are staggering. If stars can survive supernova, and not just survive but be catapulted across the galaxy, then our understanding of stellar death is woefully incomplete. There could be hundreds, even thousands, of these runaway stars streaking through the Milky Way, their metallic hearts glowing faintly in the dark. Some might even be remnants of supernova that lit up Earth's skies centuries ago, their origins lost to history. LP 4365 isn't just a curiosity, it's a messenger carrying secrets from the most violent events in the universe. And as it races onward, it dares us to rethink what we know about the life and afterlife of stars. Tucked away in the constellation Monoceros, a cosmic oddity defies everything we thought we knew about black holes. Dubbed the unicorn, this gravitational anomaly weighs just 3 times the mass of our Sun, making it the smallest black hole ever discovered and tearing up the rulebook on how these monsters form. Conventional wisdom said black holes couldn't exist below 5 solar masses. Collapsing stars should leave behind neutron stars instead. Yet here's the unicorn grazing quietly beside a red giant star, its presence betrayed only by the subtle way it tugs at its companion like an invisible puppeteer. The discovery hinged on a technique called tidal distortion analysis. As the red giant star orbits the unicorn, its shape stretches into a teardrop, not from visible gravity, but from something unseen warping spacetime itself. Imagine watching a balloon deform in midair with no hands touching it. That's the eerie signature of a black hole too small to fit the models, lurking where physics claimed none should exist. What makes the unicorn revolutionary isn't just its size, it's the implications. If one impossible black hole exists, how many more are hiding in plain sight? Current estimates suggest there could be hundreds of millions of stellar mass black holes in the Milky Way alone, but we've only confirmed about 24. The unicorn hints at an entire unseen population, black holes so petite they've slipped through our detection nets. Some might even be primordial, born not from dying stars, but from density fluctuations in the seething chaos of the early universe. Then there's the mystery of its formation. Did the unicorn start life as a neutron star that stole just enough mass from its companion to tip over the edge into black hole territory? Or was it born from a rare failed supernova, where a collapsing star's outer layers were ejected too efficiently, leaving behind a core too small to qualify under traditional rules? Even more intriguing, the red giant it orbits shows unusual chemical abundances, suggesting it might have been polluted by material from a previous cosmic cataclysm, perhaps the very event that birthed this gravitational run. The hunt is now on for more of these diminutive devourers. New projects like the Vera Rubin Observatory's Legacy Survey of Space and Time will scan the galaxy for similar tidal distortions, while gravitational wave detectors listen for the faint chirps of tiny black holes merging. Every new discovery could rewrite our understanding of stellar life cycles, proving that the universe doesn't just follow rules, it bends them, breaks them, and sometimes tosses them out entirely. The unicorn isn't just a curiosity, it's a key to a hidden chapter in the story of how black holes, and perhaps even dark matter, shape the cosmos, and somewhere out there, others like it might be waiting, their quiet gravity whispering secrets we're only beginning to hear. Most spiral galaxies follow a familiar recipe, a swirling disk of stars, gas, and dust, all orbiting a dense, bright central bulge. But the Phantom Galaxy, also known as Messier 74, throws that formula out the cosmic window. This stunning face-on spiral, floating 32 million light-years away in the constellation Pisces, presents astronomers with a paradox. It's a near-perfect pinwheel of starry arms radiating from a center so faint and diffuse it barely qualifies as a bulge at all. Most galaxies of its size should have a prominent nuclear region packed with ancient stars, yet M74's heart remains eerily underdeveloped, like a donut missing its middle. This missing bulge isn't just a visual oddity, it's a direct challenge to how we think galaxies evolve. Current models suggest bulges form early in a galaxy's life, either through violent mergers that pile stars into the core or through gradual internal processes that funnel material inward. The Phantom Galaxy, though, seems to have skipped this step entirely. Its delicate arms filigreed with young blue stars and pink hydrogen clouds spiral right into a whisper of a center, where stars are scattered so thinly they barely register against the dark backdrop of space. It's as if someone took a standard spiral galaxy and erased its nucleus with a cosmic eraser. One theory proposes M74 is a pure disk galaxy, a rare breed that avoided the chaotic mergers thought to build bulges. Instead, it might have grown quietly, its gas settling into an unusually stable rotation that prevented material from clumping at the center. Supporting this idea is the galaxy's remarkably low density of interstellar dust, another anomaly, since dust typically concentrates in galactic cores. Without this dust to cool collapsing gas clouds, star formation in the center would have been stifled, leaving the bulge stunted. But the plot thickens when we examine the galaxy's supermassive black hole, or rather, the puzzling lack of evidence for one. Most galaxies with even modest bulges host black holes millions of times the Sun's mass, their gravity betraying their presence through the frantic orbits of nearby stars. M74's core, though, shows no such activity. If a black hole exists there, it's either impossibly small or astonishingly dormant, raising the spine-tingling possibility that black hole growth and bulge formation might be more deeply intertwined than we realized. Then there's the ghostly glow of M74's spiral arms, so symmetrical and undisturbed they suggest an almost untouched existence. Unlike messy galaxies marred by collisions, the phantom structure hints at a life of solitude, its delicate dance of stars and gas left unperturbed for billions of years. Yet even this tranquility poses questions. How did it avoid the gravitational tug of war that shapes most galaxies? And why, in a universe where chaos reigns, does this one galaxy look like it was sketched by an artist's meticulous hand? The answers might lie in the galaxy's surroundings. M74 anchors a small group of galaxies, but its neighbors are all dwarfs, none large enough to disrupt its delicate balance. This cosmic isolation could explain its pristine form, but it doesn't resolve the deeper mystery of why its central regions failed to evolve. Some astronomers speculate that dark matter might play a role, with an unusually distributed halo subtly steering the galaxy's growth. Others wonder if we're seeing a snapshot of a transitional phase, a galaxy caught in the act of forming a bulge, frozen in time just before the process begins. What makes M74 truly mesmerizing isn't just its defiance of expectations, it's the way it forces us to reconsider the diversity of galactic life. For every rule we devise about how galaxies should behave, the universe seems to craft an exception. The Phantom Galaxy isn't just a curiosity, it's a mirror held up to our assumptions, reflecting how much we still have to learn about the silent, stately waltz of stars across the cosmos. And somewhere in its faint, ghostly center, the secret to its defiance might still be hiding, waiting for the right moment to reveal itself. moons are supposed to be the quiet companions of planets, small, predictable, and bound by the same rules that shaped our own solar system. But in a distant star system 25,000 light-years away, astronomers have spotted something that shatters that assumption. Meet the Impossible Exomoon, a celestial rebel so massive and so far from its planet that it shouldn't exist at all. This isn't just another moon, it's a cosmic paradox, a gravitational hitchhiker that defies every textbook explanation of how moons form. The discovery hinged on a phenomenon called gravitational microlensing, where the gravity of a star or planet bends light from a background star like a cosmic magnifying glass. In 2018, the Kepler Space Telescope caught the telltale flicker of a microlensing event, but the data revealed not one, but two objects orbiting each other. The larger one was a Jupiter-sized exoplanet, the smaller, a Neptune-sized behemoth trailing behind it like a shadow. That's no moon, at least not by any definition we've used before. With a mass ratio of nearly 1 to 5,000 between the moon and its host planet, this pairing is more like a binary planet system than anything we've seen in our own cosmic backyard. Here's what makes it impossible. Moons simply don't form this big or this distant. In our solar system, large moons like Jupiter's Ganymede or Saturn's Titan were born from disks of gas and dust swirling around their infant planets. Others, like Earth's moon, were forged in violent collisions, but this exomoon breaks all the rules. Its size relative to its planet is staggering. Imagine if our moon were the width of Australia instead of a quarter of Earth's diameter. Even more baffling is its orbit, stretching so far from its planet that it defies the gravitational stability we see in every other known moon system. Theories scramble to explain this outlier. Could it be a captured rogue planet, snared by the exoplanet's gravity in a cosmic game of tag? If so, the capture would have required an impossibly precise dance of gravitational forces to avoid ejection or collision. Another idea suggests it might be the remnant of a shattered planet, a fragment flung into orbit by some ancient cataclysm. But even these explanations strain credibility. The odds of such an event producing such a stable, long-lasting orbit are astronomically low. Then there's the microlensing data itself, which hints at even deeper mysteries. The light curve showed anomalies that some researchers interpret as evidence of multiple moons, a whole family of impossibly large companions circling this distant planet. If confirmed, it would upend our understanding of planetary systems entirely, suggesting that our solar system's tidy moon formation rules might be the exception rather than the norm. What's at stake isn't just the existence of one oddball moon, it's the foundation of how we think planetary systems evolve. If moons like this are common, then everything from our models of planet formation to the search for habitable exoplanets needs recalibrating. A Neptune-sized moon could have its own atmosphere, its own oceans, even its own potential for life. The Impossible Exomoon isn't just a curiosity, it's a key to unlocking the untold diversity of worlds hiding in the cosmos. And somewhere out there, others like it might be waiting, their silent orbits challenging us to rethink the rules we thought we knew. Hidden in the sparse outskirts of our cosmic neighborhood, a relic drifts silently through the void, a fossilized whisper from the universe's infancy. The galactic fossil, officially named Segue 1, is no ordinary dwarf galaxy. This faint, wispy collection of stars is so ancient and pristine it feels like a cosmic time capsule, a surviving fragment of the raw materials that built the first galaxies. With fewer than 1,000 stars scattered across its meager structure, it's barely a galaxy at all, more like a handful of stardust clinging together against the pull of time. Yet its very existence challenges our understanding of how galaxies form, survive, and fade. What makes this unassuming speck of light so extraordinary? Its stars tell a story written in the language of elemental purity. Unlike modern galaxies, which are polluted with heavy elements forged in stellar furnaces over billions of years, Segue 1 stars are almost purely hydrogen and helium, the primordial ingredients of the Big Bang itself. Their chemistry is so untouched that astronomers compare them to finding a cave painting preserved in perfect condition, its pigments uncorrupted by millennia of exposure. These stars didn't just form early, they're living relics of an era before supernova seeded the cosmos with metals, a time when the universe was still learning how to build complexity. But the real miracle isn't just its age, it's the fact that Segue 1 has endured at all. The galaxy's gravity is so weak that even a modest tug from a passing star should have ripped it apart eons ago. Yet here it lingers, a cosmic underdog that somehow survived the violent chaos of galactic collisions, the relentless tides of dark matter, and the explosive births and deaths of neighboring stars. It's like discovering a single, delicate soap bubble that's floated unscathed through a hurricane. The secret to its survival might lie in what we can't see. Segue 1 is drowning in dark matter, so much so that this invisible substance outweighs its visible stars by a factor of 1,000. That's the highest ratio of dark to ordinary matter ever measured in any galaxy. Think of it as a ghostly scaffold, an unseen skeleton holding the galaxy together against forces that should have dismantled it particle by particle. Some theorists even speculate that Segue 1 isn't a failed galaxy, but a successful dark matter clump that accidentally collected a few stars along the way, a cosmic accident that's outlived galaxies 1,000,000 times more impressive. Then there's the eerie silence of its stellar population. Most galaxies, even tiny ones, show signs of periodic star formation, bursts of activity where new stars ignite from collapsing gas clouds. But Segue 1 stars all appear to have been born in a single, fleeting burst more than 13 billion years ago, then never again. It's as if the galaxy froze in time after its first and only creative act, its gas supply mysteriously vanishing or being stripped away before it could craft a second generation. What happened here was Segue 1 a stillborn galaxy, starved of the gas needed to keep building? Or is it the lone survivor of a larger structure, its siblings long since devoured by the Milky Way's gravitational hunger? The answers might rewrite the story of how the first galaxies took shape. If structures like this were common in the early universe, they could have been the building blocks of everything we see today, tiny seeds that merged and grew into the glittering spirals and ellipticals we know. Yet Segue 1 never grew, it never changed, it simply persisted. Now, as it orbits the Milky Way like a shard of cosmic driftwood, it offers us a rare gift, a direct line to the universe's darkest, most formative age. By studying its stars, we're not just observing a galaxy, we're decoding the conditions of a time before time as we know it. And somewhere out there, other fossils might be waiting, equally fragile and ancient, their quiet light carrying stories we've only begun to imagine. Segue 1 isn't just a curiosity, it's a portal, a window into a past so distant it defies comprehension. And in its faint glow, we might finally find the missing links to our own galactic origins. Behind every cosmic anomaly we've explored lies a deeper question. What isn't the universe telling us? These structures aren't just oddities. They're breadcrumbs leading to gaps in our understanding, places where the rulebook of physics appears to have missing pages. Take the Fermi Bubbles' unexplained gamma rays, or the Great Attractor's invisible pull. Each one behaves as if there's an invisible hand tweaking the equations, a set of variables we haven't accounted for yet. Dark matter is the usual suspect. We've long known it makes up 85% of the universe's mass, but discoveries like Dragonfly 44, a galaxy made almost entirely of this mysterious substance, force us to reconsider its role. Maybe dark matter isn't just a passive scaffold holding galaxies together. Maybe it's an active architect capable of building structures we can't see and influencing phenomena we don't yet understand. The way it clusters in filaments to form the cosmic web suggests an underlying order, a hidden logic to how matter organizes itself. But why does it sometimes pool into dense halos around galaxies and other times vanish entirely, as in the Boötes Void? The inconsistencies hint that dark matter might be more complex than a single particle, perhaps a family of particles with different behaviors, or even a shadow universe with its own rules. Then there's the unsettling possibility that we're dealing with more than one unseen force. Dark energy, the enigmatic driver of the universe's accelerating expansion, might also play a role in these anomalies. Could it be tugging at galaxy clusters to create the dark flow, or stretching the Hercules corona Borealis Great Wall into impossible scales? The trouble is, dark energy is supposed to work uniformly, a gentle pressure applied equally across the cosmos. Yet these structures suggest localized, uneven influences, like finding footprints in the sand that don't match the tide. And what if the answers lie outside our universe entirely? The CMB Cold Spot's bizarre chill and the dark flow's coordinated motion have led some theorists to propose a radical idea. We're seeing the gravitational fingerprints of a neighboring universe. In multiverse models, other cosmic bubbles could exist mere millimeters away in higher dimensional space, separated by membranes we can't perceive. A collision or close pass between universes might leave imprints in our sky, cosmic bruises like the cold spot, or tidal pulls like the dark flow. It's a staggering thought that the greatest mysteries of our universe might not be ours at all, but echoes from a reality we'll never directly observe. Perhaps the most humbling takeaway is how little we truly know. For all our equations and models, the universe keeps presenting us with structures that defy categorization. Hoag's object shouldn't be so symmetrical. The Saturn Hexagon shouldn't maintain its shape. The impossible quasar trio shouldn't exist. Yet they do, whispering that our current laws are incomplete, like Newtonian physics before relativity, or classical mechanics before quantum theory. Every anomaly is a clue, a nudge toward a deeper framework that might one day unite these contradictions. The real question isn't just what these structures are, it's why they're testing the limits of our knowledge so insistently. Are we on the verge of a paradigm shift, like Galileo realizing the Earth wasn't the center of the universe? Or are these anomalies cosmic red herrings, distractions from a simpler truth we've overlooked? One thing's certain, the universe isn't just stranger than we imagine. It's stranger than we can imagine, and every bizarre discovery is an invitation to look deeper, think broader, and embrace the chaos of the unknown. The anomalies aren't flaws in the cosmos, they're its most important lessons, written in a language we're still learning to read. From colossal gamma-ray bubbles erupting from our galaxy's core to ghostly galaxies made almost entirely of dark matter, these 30 deep space anomalies aren't just cosmic curiosities. They're signposts pointing toward the gaps in our understanding. Every time we think we've mapped the universe's rulebook, something like the Great Attractor tugs at entire galaxies, or the impossible quasar trio defies probability, and we're forced back to the drawing board. These aren't just puzzles to solve, they're invitations to rethink reality itself. Consider how much we've already learned from these enigmas. The Fermi Bubbles taught us that black holes might belch energy on scales we never imagined. The Methuselah star proved the universe could craft ancient relics older than we thought possible. And the unicorn black hole, It shattered the very definition of what a black hole could be. Yet for every answer, a dozen new questions emerge. Why does the Saturn Hexagon keep its geometric perfection? What carved the eerie symmetry of Hoag's object? And what or who sent the wow signal? The beauty of these mysteries lies not just in their strangeness, but in their persistence. They resist easy explanations, daring us to dig deeper, build better telescopes, and question long-held assumptions. Maybe the answers lie in physics we haven't discovered yet, dark matter interactions we can't see, higher dimensions we can't perceive, or cosmic forces beyond our current math. Or perhaps the truth is even wilder, that the universe is far more creative, more unpredictable than our models will ever capture. So what's next, with breakthroughs like the James Webb Space Telescope peering deeper into the cosmos than ever before, and projects like the Vera Rubin Observatory set to scan the entire sky nightly, we're on the verge of uncovering more impossibilities. The next galactic fossil, the next rogue black hole, the next signal from the void, they're out there, waiting to append another piece of our cosmic worldview. This is why we explore, not just to check items off a list, but to stay humble, to keep wondering. Every time we point our telescopes at the unknown, we're not just seeking answers, we're rediscovering how vast, how bizarre, and how breathtakingly alive the universe really is. So tell us which of these cosmic rebels captivates you the most. Drop your favorite in the comments, and if you're hungry for more mind-bending space mysteries, hit that subscribe button. The cosmos has plenty more secrets to share, and we're just getting started.